So what is Python? I'm sure many of you are either in the curriculum of the courses or having some experiences. So you must have heard what is Python, and there's a lot of bubble around it. All right. So Python is one of the programming language which was introduced around 1989. All right, and primarily it got the limelight post 2008 or 2009, I would say, when the bubble around data science and big data got busted. And Python is the predominantly used language when it comes to solving the data science or ML or deep learning problem statements. Okay, so I won't say that this is the only language, but in industry, the I would say the 90 to 95% time you will see the applications are getting developed and deployed in Python only. Okay, so what Python can do? All right, so as I said, Python is not a new language. It's a pretty old language. 1989 or 1990 it was developed, so it's around 25-30 years now. And why Python got so limelight in recent years is because you can see on the screen, Python can be useful in developing the games. All right, it can be useful in designing the enterprise level solutions end to end. You can even go ahead and build the websites out of Python. All right, you will be surprised that Twitter is primarily built in Python. Majority of Instagram is also built on the Python. So Python has that level of capacity. As I said earlier, the majority of businesses in the analytics division or the machine learning division is primarily used in Python. All right, there are a lot of databases. There are purely, you can say, Python is a high-level language where object-oriented is also supported. All right, so OOPS concept like classes, inheritance is also developed in Python, and these are some of the banners that you see where Python is primarily used. And I can tell you with confidence that nowadays you won't find a single company where Python is not used in any capacity. Okay, so some may be using it for data science or ML practices. Some may be using it for the web development. Some may be using it for heavy data processing. So in any capacity, you will see these companies are using Python, and people who knows Python at a great level have a good demand in market today. Okay, so in my company also we hire Python developers very frequently, and the good part is Python is very easy to learn. It's not difficult language, or it's not the complex language structure like COBOL or C used to be. It's a pretty simple language to learn. All right, so yeah, as we were discussing earlier, what are the applications or the use cases of Python? All right, so this is the slide which can tell you that in which direction or in which what you can say, the areas in which you can go once you know the language at a good pace. So you can be a web developer using Python because there are wonderful frameworks which is available in Python that we will be learning in the courses going forward. Of course, data science, data analytics are the core engine of Python. You can do an SDLC like a typical software development. There are big frameworks for testing, like we do it in JMeter and that stuff. So that is also available in Python. One of the principle that is getting a lot of momentum from last couple of years is RPA, that we call it as robotic process automation. Python is doing very well with that kind of a principle as well, by combining various tools, by doing an integration at their end. So yeah, RPA is also the field where you can definitely put your steps. Again, who is interested in doing a game development, Python is the language. You can definitely go and check it out. There are wonderful examples, articles you can find how the game has been developed in Python, being a lightweight language. You can be a full stack developer. All right, so what is a full stack? Full stack is a person who basically knows multiple languages and multiple frameworks, like from the front end to back end and to the database layer, who can combine all of this together and make an application. That's kind of a full stack. Python is a useful tool there as well. All right, so these are the broad areas, basically we can say these are the broad channels in which you can diversify yourself once you have a good hang on the Python language. All right. So before I move on, I would like to hold on for a second to check if anyone have any question. You can put there maybe in the chat window and I can just answer it for you. Till the time what we have seen, like what is Python, where it is used, how it is used, and then we can check that what you will be learning in the courses that we have and how it will be useful for you. Any questions so far? All right, so as there's no question, preferably let's move on. So these are the broad pointers which you will be learning out in the courses that is coming up to you. All right, so if you see on the left, these courses are designed in such a way that you start yourself from the basics, then we move on to the intermediate level, and then at the end of the course you will be hands-on with the most advanced topics. All right, so if you see on the left, any language, if you want to learn it with the ease or with the power that you'll remember it for a longer time, you have to learn the structures of the language, you have to learn the principles of the language. That is what you will learn in what is the data structures of the language, what is the variables, how that is interrelated with each other. And then there are components of the programming language. I'm sure you have some of the other knowledge of any other programming language, then it is like a piece of cake for Python. So you can learn what is functions, what is iterations, what is lambda functions. So these are nothing but components which makes Python language such an easy language. We will be learning it with examples, with practical for each and every topics that you see here. Python is a language which is heavily dependent upon the packages. Okay, so there is a wonderful community of a Python language, because Python being an open source, it has a huge community. Okay, and this community develops the third party packages. So let's say if I have created something, I will be able to pass the same work to you in terms of package. So we will learn how this package is created, how the package is is useful, how do you use it, how do you integrate it, which packages are useful in terms of doing your work in a day-to-day fashion, because I come from that industry, so that I know which all packages or what importance every package carries. All right, as I said earlier, many people have no idea that Python is an object-oriented language. So you can write classes, you can do a whole lot of polymorphism and object encapsulation using Python, which is not very difficult, such as in C++ or Java. There's a whole set of tool set which we use in a production level application to doing error handling, exception handling, error management, and we will see an example and practical of each and every of these components, so that you get an idea that how do these components are first managed in Python, the second how do we use it, and third how do we integrate it with each other. Okay, if you see the middle part where it is a framework, as I said earlier, people who are interested in going towards the web development or the game development, they need to know this kind of frameworks, which are like a web frameworks. So we will be seeing examples, demos, and the projects for this web frameworks, which are two very predominantly used web frameworks in Python. One is Django, one is Flask, and we will see that how to use it, where to use it, and you will be creating an application by yourself. The third you see is again error monitoring. As I said earlier, we will be doing a lot of practices about the error and logs. And lastly, we will see what are the IDEs that you can use with Python language, and there are plenty of it. So we will be seeing example of each one of them, so that you can choose one of your own favorite. It's not that you have to use only one. All right. Now, what is data science? All right, what we see right now is just a Python language. And as I said earlier, Python language is one of the medium by which you can solve or you can do a data science. All right, it's not the only medium. So Python is one of the most used medium. And now let's see what is data science. There are a lot of buzzwords around it. There are a lot of bubble around it, and every day you will see that people talk about it. All right. So if you ask me, what you see on your screen is basically two things. One is an explanation of what it is a data science, And second, a life cycle of the data science. You see those arrows, and I'll explain each of them in a bit, but this is broadly the component in the life cycle of the data science. All right. So data science is a principle, or it's a what you can say a practice, which is a multidisciplinary principle. So when I say multidisciplinary, what it means is the field of data science is created out of merging multiple fields such as maths, statistics, programming language, logic, and your machine learning algorithms, your DevOps, your software maintenance, your software development. All these components, when combined together, plays their part and makes data science as a field. All right, and that's why when you ask someone what a role or what activities data scientists do, he will, or there is no predefined definition for it. All right, there are a whole lot of things that as a data scientist you have to perform on a day-to-day basis, which I'll explain in every phases. All right, so the major the start, I'll just show you here. So the data science field starts basically from here. All right, however, the data acquisition field that you see before that, there is one more phase, is problem understanding. Okay, so any data science, any machine learning problem always starts with a problem statement. Okay, now problem statement can be as small as saying that I want to increase my sales by 15% in next quarter. That's a problem statement. Another type of problem statement would be I want to reduce my customer churn by 3%. Again, that's a problem statement. So problem statement is nothing but an objective that a business wants to solve in a predefined time. Okay, now how do you solve that problem is the process of data science. Okay, the major, or you can say the core component of solving that problem is use a data which is historical data, which can be available in your organization itself. So let's say I am a bank and I want to increase my sales by 10%. So that's a problem statement which I have made. Now how do I solve it? So the first thing I do is I collect a data which is useful in order to solve that particular problem statement. All right, so my data could reside in my own organization. Okay, my data can be available in social media. So when I say social media, I can think about I can check what people are talking about my products on Twitter. Are they writing good reviews? Are they writing bad reviews? So that is one of the medium from where the data is collected. Second is, I can go ahead and do a survey. I can typically, ask people to take a, participation in the poll, that what do you think about the products and services that I'm offering, or what are the new features that do you want to see in my product. So these are the fundamental methods by which you take the data. Okay, that is a data acquisition phase. Sometimes you connect to your, vendors or your partners and collect the data. But the fundamental idea is, one, you justify what is the problem statement. Once you justify what is the problem statement, you always know what type of data you have to look for. Once you do that, you have to find a channel by which you can collect this data. Okay, maybe your own company, maybe a third-party vendor, maybe a not directly customer, or there is a social media. That's how you collect the data. All right. Now, one of the major problems with computers from the initial days is computers cannot understand anything beyond numbers. Okay, so even if you pass a simple tweet to computer, it won't be able to understand it. Or if you pass a data which is like a video, your computer still won't be able to understand it, no matter how supercomputer it is. All right. So when we say a data preparation, all right, so that is the second stage. So data preparation is a stage where data analyst or data scientist spends his huge amount of time. All right, I'll just give you a few examples that what do you mean by data preparation. All right, so sometimes what happens is that you get a data in a format that is not useful for your analysis. So imagine you're collecting data from Twitter. So when you try to collect the data from Twitter, you will end up realizing that you're collecting a lot of garbage values. Okay, there are a lot of values or a lot of fields that you don't even require, but it is still coming. All right. Second example would be, you're working on some employee or HR data sets. Okay. And you have a employee table where you have a one field as a salary, which will be in lakhs. Okay. As a per annum. So someone will have 6 lakh, 10 lakh, 20 lakhs. All right. And there will be another field, which is like distance traveled by employee every day between the home and office, which the units will be in tens, right? Generally 20 kilometers, 30 kilometers at max. But now when you try to do a modeling on it, or when you try to do an analysis on that, try to see the difference between two columns. One of your column is having units in lakhs, and second of your column have units in tens. So when you compare these two numbers, or when you try to put up a visualization of this particular data points, you will not be able to analyze on the one ground, because the scale is so different for both of them. So as an analyst, as a data scientist, you need to understand these facts. And with an example that we will take in the courses, you will realize when to look for this kind of loopholes, how to identify them, and how to treat them. Okay. And once you prepare your data in a way which is on the same ground and is ready to use for your further explanation, we move on to the next stage, which is called as exploratory data analysis. Okay. So there is one fundamental principle that I have been following throughout my career, is the success of your data science project, no matter which project it is, how big it is, how small it is, the success of it will always depend how much time you are spending in these two stages, the preparation and data analysis. Okay. It is directly proportional to the success. So if you spend more time here, you will tend to get more success in your project. And if you don't spend much time here, the probability of getting a success is pretty low. Okay. Because in data science or in ML, there is one fundamental principle, is garbage in, garbage out. So what you feed into your machine learning algorithm, it will throw out the same to you. So if you feed in garbage, you will get the garbage back. But if you feed something meaningful, your results will be meaningful again. Okay. So what do we mean by EDA, or what do we mean by exploratory data analysis? Okay. So let's say once you prepare your data in some or the other format, which is like in the same ground, before applying any algorithms, which is the third step, like data modeling, before applying any kind of an algorithm on it, you need to understand what data you're working on. Okay. So some of the examples I can give you is, let's say you're working with the same employee data set. All right. And you see that age is, in minus, or you're seeing age is like 150. Now, obviously there is something wrong with the data. Maybe, it's a data entry error, or maybe it's a error from the machine side, or it's an error while, transmitting the data between two systems. It might happen. All right. The second example I could give you is, once you're doing a text analysis on Twitter data that you get, you might find out some abusive words, which is not helpful in doing any analysis. So being an analyst or being a data scientist, you need to track this kind of a thing. And when you are in the early stages of your career, like you're now, as you are on the urge of becoming a junior data scientist or junior data analyst, you will play a key role here, because when you enter any organization, they will first provide you this kind of a work where you have to spend a lot of hours in doing an EDA, doing a data preparation. You will be working under a senior data scientist, and we will be guiding you to do that. Okay. So what you really need to understand is that how a good data can be prepared. So if you put yourself into the customer shoes, you will realize that the data that you are getting and how you can make it more useful. Okay. EDA would be another example I can think about is, when you get a data, you will see a lot of missing values, because it's pretty common nowadays. So you will, have no values in columns. So what do you do about it? So there are a lot of principles, there are a lot of methodologies which you can apply, which are industry standards, and which we have been doing it over the course of our journey, and we will be looking at that in practical every session that we do. Okay. So once we do this two stages, the third stage, which pretty much today's people are very interested is doing, is ML. So this part is nothing data modeling, but nothing but an ML. So here is the place where you actually apply your machine learning algorithm. Like algorithms, I won't go into much detail because this is not the right moment to dive into it, but I'll just give you a brief. So machine learning is nothing but a set of mathematicals, formation, which allows you to explore your data, and it helps you predict the data points into the future. Okay, so it's mathematical formulation. Now there are multiple branches of algorithm. One is regression, where you are trying to predict a continuous data point like sales or height or maybe salary. So that's a continuous data point. All right, so that's what we call as a regression problems. Second set of problem is a classification task, where you're trying to predict yes or no, maybe a, so in a layman's term, you're trying to predict a definite set of values, male, like gender, male, female, like whether a customer will default yes or no. So when you deal with that kind of a problem statement, it's a classification problem statement. And once you identify what type of problem you're trying to solve, there are tons and tons of algorithms which are available into market. And trust me, you will see new algorithms coming every month. There are a lot of research people around the world working to create new algorithms every day. So you will find new algorithms that are coming every day. Few algorithms are very good on few sets of data set. All algorithms does not perform really well on all data sets. So we will be deep diving into it when we see the actual practical into the course, duration when we see. But that's what the data modeling part is. And after that, once you create your model, once you know that you have come up with a mathematical equation which is explaining your data so well, then you have to explain that data, you have to explain that results to the stakeholders, like what we call as visualization and communication. So there will be people who will be stakeholders like the VP of the company or the people who want to solve this problem. Okay, once you spend a good amount of energy, efforts to solve this problem, you will go back to them and you will try to explain what you have learned or what you have created. Now, one of the major challenge with data science, field is that even if you try to explain to them the numbers, because the machine learning field will give you numbers as a result, will give you probability as the result, which we will see in a couple of minutes. The output that you will see is always the probabilities or the numbers. So if you try to explain that to someone who is not well versed with these methodologies, they will not be very much interested. They will be, feel lost. So you will have to create a story. So I always say this, that a good data scientist have to be a good storyteller. Okay, because whatever result you have generated out of all the stages, you have to create a nice story around it, which you can explain it to any layman and he can understand what you're trying to say. Okay, what is the pain point? And once you do that, if your all stakeholders are mutually agreeing that what you're creating is really beautiful, really meaningful, and it can save a lot of money and efforts for us, you will deploy that particular thing into a production servers. Okay, and deployment is another critical task, which we will talk in lot detail when we come to that stage. But deployment involves a lot of teams. Like major challenge which I have been facing today's time is when I deal with banks, the bigger banks, they are using traditional systems like developed in 1980s or 1985. Now those systems are working perfectly fine. They have no issues whatsoever. But when is the point to integrate these two systems like advanced machine learning or deep learning algorithms with those traditional systems, it's a lot of pain. Okay, because they don't merge or gel well with each other. So you have to find new ways. You have to be in talk with continuously the architecture heads, the deployment people, the software team, the infrastructure team, and you have to find out a way balanced method that how can you deploy that. But again, I don't want to scare you now, but you have to keep that in mind that as a good data scientist, you also have to think about how this machine learning algorithm that you have created could be put up in a existing ecosystem and how it can be useful for every department that is engaged with it. Okay, so this is broadly the life cycle or the components of the data science field or any machine learning job that you will take. If you find on Google, you will find more or less similar slides or similar components. But I think this pretty much explains what you will be doing as a data scientist in near future, or what in a nutshell the entire process looks like. Okay. So before we move on, I would like to take a 2-second pause and ask if anyone have any question so that we can solve and move on. Anyone, any questions? Or you can have suggestions, am I going too fast, too slow? It's perfectly all right.
Not really, Puneet. It's going well.
Okay, cool. So I think Sunny is typing something. No, everything is going smoothly. Perfect. So I think we have no questions, so we will go ahead. All right. So as we were saying earlier that, data science is so well, and nowadays everyone is talking about, one of the funny observation that I have had in recent time is, no matter which mobile app you see, or no matter which website you see nowadays, they will use these buzzwords: data science, machine learning, AI, cognitive intelligence. All right. So it's like a mandatory paradigm that every company is facing. Okay. However, these are the, what you see on your screen are particularly the domains, I would say, the industries which is very highly affected by the data science field or machine learning, bubble from last 5-7 years. And, I'll take one of the examples for each of them so you can relate it once you, go back. So travel, if you see in recent time, like companies like Airbnb, okay, or companies like the people like Google Flights, okay, they have been using data science or ML algorithm in such a way that they try to give you the optimized flights. Airbnb will try to give you the price which is decided by the algorithm, okay. And I don't know how much you are well versed with Airbnb business model, but Airbnb business don't allow owners to decide the price. Airbnb itself decides the price. And how do they do that? It is based on the month where it is mostly occupied or not, the location, past history of movement of travelers, all that is considered, and they come up with this price. So that is how the travel industry has affected so much. Marketing, what do we talk about it? Any industry that you see nowadays, banking, retail, e-commerce, they are using, or they are creating so much of digital content that you follow, and then based on that they cross sell or upsell to you. So when I say digital content is what you might have observed this in your social media browsing, like you see on Facebook or Instagram, you will always see the ads which is more relevant to you. Okay, so just an example, if you search something on Google like Nike shoe, you will see more of a shoes ad on your Facebook or your Instagram account. Now that's not a magic, okay, it's just a data collection pattern recognition, and then you put up the same thing on your social media accounts. That's how you create an urge in the customer to buy that product. So that's how the marketing is playing, and that's a huge industry, and many key players are turning up in the AI field. Okay. Third is healthcare. Again, one of the main industry where data science have done so wonderful job. There are so many use cases that I can talk about in healthcare. In recent days, the issue of the COVID period that we are seeing, one of the two brilliant people from IIM Ahmedabad, okay, they recently came up with a image classification program using a basic or CNN architecture that I would say. They have created a methodology by which your chest X-ray can tell you whether you are a COVID patient or not. And that's a phenomenal thing to do, because if you look at the existing method, it takes 2 days, at least 2 days, looking at the population and dynamics of our country. It at least takes 2 days for you to get the result. However, these two gentlemen, and they are very young people, they have created this methodology. If you scan the chest X-ray, that system then and there will tell you how much probability is that you are a COVID patient. So that's phenomenal. There are another use cases I can take is Google and Indian Health Association came together to talk about the throat cancer. Okay, people were not having a lot of equipments in India in the couple of years back. So they came together and they devised image classification program again, which is now efficient enough to tell you whether you have a throat infection or not in 2 seconds. That's it. That's the power of machine learning in healthcare, and it's a big field. Everyone is doing a lot good stuff there, and I'm sure the vaccination on COVID will be very pretty much soon in the market using this technology. There are a lot of experimentation is going on in this field. Social media, again, I think I don't have to talk much about social media because we are heavily users of social media. So just one example I can give you is Netflix. If you see one serial of any particular genre, you will always get the similar recommendation. I mean, I know it's a pretty old example, but it's most effective. Netflix entire business model is dependent upon this. So that's how they're doing or using data so much. Sales, again, as we talked about in the marketing use case, they will create a demand. Earlier, it was, a case where people used to buy only when it was required. Nowadays, using data points, companies are actually creating a demand. Okay, so Amazon, Myntra are the ones who are best example. You will see that. 7 is again a BFSI domain. I mean, I think the banks and the insurance firms are the most organization which are using data to the core. All right, like identifying of fraudulent transactions, or maybe to whom I should give a loan. Okay, when you apply for the home loan or a car loan or a personal loan, there is a credit score rating which goes into the process, which is like earlier it used to take a days. Now it takes minutes because the entire process is converted into an algorithm, which I have done it for a few of the banks, and I have been keep doing that, and it's now a standard practice for everyone. So that's how it is affected. There are many use cases in the banks as well. Automation is again, I mean, it's a boom in the automation. Like Elon Musk have created the self-driving car craziness around the world, and the core component of a self-driving car is nothing but a deep learning modules. Like how do you identify is some object is a tree or a person or something else? It's nothing but a deep learning modules, and we will see that deep learning models in detail. How do you create them? How do you use them, and what are the applications? So these are, I think, the broad industry where these are affected heavily using data. And one of the good part that I would like to mention here is that we have use cases for every industry. All right, so no matter if you take healthcare or travel or sales. So as I come from industry from 8-9 years, and I have worked on those domains for a quite long time, so I have a use case which we will solve together for every domain. So if you are from a bank, you will be most relatable to that particular use case, or if you come from a healthcare background or a digital marketing background, you will be relating to that particular use case so well that you can make that connection. So that we will do as and when the course moves on. Again, these are some companies who are heavily doing the data science or analytics as a standard practice, and I can say this with confidence that there are far more companies who do data analytics, and I don't think even there are any companies left who is not joined the parade of data science or analytics in their company. So everyone is doing data analytics, data science in some or the other capacity. If they don't have the buying power, they will hire someone to do the data science for them. But yes, data science is the ultimate solution that everyone is looking at. So in the course that we will be doing for data science is something that is in your desktop right now, that what you will be learning there. So as I said earlier, if you remember, Python is a language which is heavily dependent upon the packages created by the open source community. Okay, so we will start learning those packages which are heavily used in machine learning or deep learning fields. I don't know if I'm sure you would have heard somewhere that NumPy, Pandas, scikit-learn are the libraries which are heavily used to do any machine learning task, and we will deep dive into those libraries so that your basic concepts are so clear that you can use it to the core. Okay, NumPy is the library which helps you to do huge calculations in seconds. Okay, so it's a numerical library. Pandas helps you to do data manipulation, all sorts of manipulation that you can think of. Okay, we will learn how to create nice visualizations. So in the next 5 minutes, I will take you to the practical demo, and I will show you that how wonderful visualizations are created in Python with the ease of coding. And we'll see those packages. How do we do it? How do we use it? How do you tell the story? Okay, I'll show you that in a couple of minutes going forward. We will deep dive into mathematical concepts, especially behind the algorithms. So when we say logistic regression, we just won't say logistic regression in a library methodology. We will deep dive into see that how mathematical formula take place. Okay, how do you pass the data in, what calculation happens in the background, and what kind of an output you should expect. Majority of the time we will spend upon how do you fine tune it. Okay, so majority of the time you don't see that your base version of algorithm performs really well, but what we can do is we can fine tune it. All right, and we will deep dive into that every time we will see any algorithm. And again, on the right hand side you will see is a lot of IDEs like RapidMiner, Jupyter. We will learn that how do we use it, how to integrate it. We will talk about a lot of data cleansing tools, data which are used on day in day out. And by the time we finish that kind of a module, you will be more comfortable in doing any kind of data cleaning that is required. Okay, and I'll be the one who will be guiding you that what kind of data cleaning tool are required in what kind of scenarios. Okay, and you will be very well versed with that as well. So we will do all this stuff in a very detailed manner, in a sequential manner when we go into the deep courses. So now a lot of theory we have talked about, a lot of knowledge that I have passed on, but I'll show you in 5 to 10 minutes what actually a real action looks like in Python. Okay, and I'm sure it will clear a lot of your doubts, and I hope it generates a lot of question in your mind which you can ask. But let's deep dive into it. So before I show you the real action, what I want to tell you is what is the use case that we are taking, okay, or what is the problem statement that we are first identifying. So we are looking at a data statement which is like, I'm a bank. Okay, let's say I'm a VP of a bank, and what I am seeing is that a lot of customer is leaving my company or leaving my bank. So I have been seeing that a lot of customer is getting churned out, and I want to do something about it. So I go to my data science team and I tell them, boss, there are so many customers that are leaving from our company, our bank. Let's stop that. What can we do about it? And then data science team goes back and look at the data, and that is what exactly we will do. Okay, that is what we will actually do in the Jupyter notebook, which I'll show you just now. So these are some snapshot, which is fine. I can take it later on because, okay. So I hope you can see the screen, right? The Jupyter notebook, you can see that?
Yes, Puneet.
Perfect. So this is one of the IDE or one of the tool in which you can do Python programming. I personally use Jupyter notebook, I think 30 to 40% time of my day. It helps me do a lot of experimentation before I put it up into the actual code. Okay. So on the first box that you see here, I'm just importing a lot of libraries. Like as I said earlier, import pandas, import numpy, import cbon. So these two are the fundamental libraries that I use, and these two are the data visualization library. Now I won't go into much of the detail because we will definitely deep dive when the real time comes. Okay, and here I'm just reading my data set. Okay, it is so easy that I just write one line like pd.read csv because I'm reading a CSV file. Okay, and this particular function comes from my pandas library. Okay, once I read the data, the most fundamental step that any analyst should do is look at the data, how it is looking, and that is what we are doing here. So when I say head, it will print first 5 records for me. So if you see here on your screen, This is how my data looks like. I have a customer ID as a field. I have a surname. I have the credit score, which location they are from, what is the gender, age, tenure is how long are they, my customer. What is their active balance right now? How many number of products they are using from my bank, like credit card, personal loan, bank loan, and all that stuff. Then whether the customer have a credit card or not with me. So 1 is yes, 0 is no. So 1 and 0 in data science language, we call it as a dummy variable or one hot encoding variable. So 1 represents yes, 0 represents no, right? Whether the customer is an active member. So by definition, active member is whether he has done any transaction in last 3 months or not. All right. So if he hasn't done any transaction in last 3 months, I will classify them as a non-active customer. So if you see again the same fundamental logic, 0 is no, 1 is yes. And this is a estimated salary. Okay. How much is the salary of a person? And exited is my target column. Okay. Or exited is the column which I'm very much interested, which tells me whether this customer have left me as a customer or whether they have gone out of my system. So again, 0 means no, 1 is yes. So similarly, head, there is one function called tail, which gives me the record set from the end. So one way to identify that is verify is that if you see here, this is the index. So it tells me 0 to 4, but in the tail it tells me 4,995 to 5,000. All right. So simple data frame I have, simple data I have collected. And as I said earlier, okay, so if you see in this stage, I have collected the data. Okay. Now majority time we will spend in this two, EDA and data preparation. So let's do that. Okay. First is what I always do is I try to see if there is any null values in my data set. Are there any columns where we don't have a data at all? Okay. So this is a heat map that we call it as a heat map. So I have practiced to create a heat map. So if there is a data, if you see here, there are, I don't know if you can see, these are the column names. Okay. And I have all in the same color, which means I don't have any missing value in my entire data set. Now this is a hypothetical case, but I just took it to avoid the complexity looking at the time. Another method to check whether I have any null values, if you see on your screen, again it's like a one-way statement. Pretty much I'm using only the fundamental functions of pandas like is NA, and I will be teaching you this into very detail when we go on to the class. So if you see here, these are the columns and these are the count of null values, and we can verify that all columns have a 0 null values. So it's pretty good for us that we don't have, or we are not going to deal with null values. Pretty good. I will again deep dive into what are the data set that I have. Okay, so if you look here, I have these columns. So this is another very useful function provided by pandas. So these are the column names again. If you see here, I have a 5,000 entries. Okay, and I have a total of 13 columns. So it's pretty easy to get the basic flow of my data that I'm working on. And these are the data types for every column, like integer, object, float. All right. So it gives me a brief, idea that what is the data that I'm working on, right? One of the another very useful method which I use it every day is describe. So what describe does is it gives you a 5-point summary of your numeric columns. Okay. So what is a 5-point summary? 5-point summary is a statistical term. Okay, which includes your minimum value, maximum value, and then your average value, your standard deviation, and your 50% quantile. All right. So this is what the 5-point summary is. So if you see here, age. Okay. So what is the mean is my average age is 38.92, which is 39. The standard deviation is 10.63. The minimum value that I have seen in my column age is 18, which is good. The maximum is 92. So I mean my data is in good shape. All right. This is a 25% quantile and this is 75. So this is how you can check for the data. And I'll tell you something which is very interesting. It is balance. If you see here, the minimum is 0. So for sure, I know that there are few customers for which they maintain 0 balance always. Okay. And if you see maximum, it's pretty high, 2,50,898. So my range of values is very wide. And if you see here, the average is 77,000 approximately, which is pretty high considering people have 0 balances. And standard deviation is 62,107, which is what you can say, a proof that my data is heavily skewed. And when I say skewed, it means it is widely spreaded. And I'll tell you how you can do that. So my basic point of telling you this is, as an analyst, as a scientist, you should have this kind of a mindset to read the data so well. Okay. And it doesn't come overnight. As we will solve a lot of use cases together, you will be able to do that with me. Okay. Now, this is again, this was one method of doing a data analysis or data understanding. Another, proven method to do a data analysis is a visualization. Okay. Because as there is a saying that picture says more than 1,000 words, and it is true somewhere, I believe that. So if you see here, I'm just trying to see that how my exited or how my people who have left the company is distributed. So one good thing is I see a lot of customer is still with me as a 0, but I see there are a lot of around 1,000 people have left me. Okay, which is a bad, but we will see why and what happened there. So it's pretty, if you see here, it's a couple of lines of code, and this creates a wonderful image for me. The good part is I can even save these images. So, it helps you to create a presentation or PDF to present it to, stakeholders. If I go down, I want to see the people who have left me are whether active people or the people who are not active and then they have left me. Right. So you see here, I've added one more dimension to the visualization. And surprisingly, if you see, the blue bar is very high for the 1, which simply means that the people who are active, they're leaving my company, which is a bad sign for me. Right. And if you see here, the people who are staying with my bank are not active customers. Right. So this kind of an analysis we have to check when we do a data visualization study. Again, if you see here, I'm doing a gender-wise classification, and I can see that female customers are not pretty happy with my service, and they are the, heavily customers who are leaving my services, and males are the one who are staying back. Okay, so point is, you have to create this kind of a stories which you can tell it to the decision makers, I would say, or the stakeholders who have no connection with the statistics. Because if you tell them that 390 people are staying and 590 people are not, they won't make sense out of it. They will only make sense when you tell them the story in this way. And this is coming out of my experience for dealing with so many people, and they only understand when you create a nice story around it. So always make sure that you create a nice story. Okay. Now again, this is one of the method when I'm trying to see what is the distribution of my age, and we can pretty much see that it is a normal one where I have a measure of the people into the middle age. Okay, so if you see here, like from around 26, 27 to 45, my majority of the customers are lying there, which is good. Now this is one of the interesting fact that we saw earlier is this is the distribution of my balance. If you see here, all this codes is, all this visualization is created only in one line. So this is the code for it. Okay, and if you want to compare it with any other programming language, there will be more than 5-7 lines of code. However, Python is pretty much simple here. So the point of distribution here is, if you see, as we saw earlier, my majority of the customer is with a 0 balance, which is pretty bad. Approximately around 1750 customer is a 0 balance, and there are only few customers who are following this balance trend. And I think this makes sense because when we see here, the balance is 0 and the average is 77 approximately, because only few people have a non-zero balance, and which is pretty much clear here, right? So this is how you have to make a correlation. This is how you have to make endpoints for stakeholders to follow you, and then you tell them what are the solutions around it. Okay. This is one of the I would say a little detailed graph. So don't take it too much, but then box plot is one of the plot which helps you identify the outliers or not normal data points in your data set. Okay, and we will see all of them in a very great detail when we actually deep dive into the course. But the idea is to see what is the distribution of my users based on the number of products that they have consumed from me. Okay, and I can see that the people who have consumed 3 products or 3 services from me have a huge number, and they are pretty much into the middle age, like 40 to 50. And the people who are consumed only 1 or 2 services are pretty younger than the ones who have consumed the 3 services. So there is a scope for a business that they need to do more selling to those people, the young people, and sell more products to them. Okay, so that is a data point that we need to provide, and the action items that we can provide it to the what you can say, to our stakeholders. All right, so this is a fundamental methodologies by which we can analyze the data. We can see what data is about and how do you prepare a story around it. And as I said earlier, the much amount you spend here, the much is the probability that you will get more success. Okay, and from here on we do data preparation for our algorithm stuff. So I would like to take a 1 second pause. I think we still have a 7-10 minutes left to cover. I'll wait for 5 seconds to ask if anyone have any question. Okay, I think we are pretty good to move on. All right. So from here, if you see, what am I doing is there are a few fundamental functions that I'm using, get dummies, because let's see our original data. Yeah. Oops. Yeah. So if you see here, as I said earlier, the machines, no matter how good, bad, how big, small it is, it cannot understand anything apart from numbers. Right? So if you see here, my gender column has male, female, which is a string or maybe a character. My geography has again a character, and similarly my surname is again a character, and I definitely cannot pass this to any algorithm. So one fundamental thing is I have to deal with them. Okay, so that is one actionable item for me as an analyst. So that is what I will do here. Okay, so in statistics we call something as a dummy variable, or we something called as a one-hot encoding, which I told you earlier. And this kind of a functions like get dummies. So if you see here, the ease for a programmer is so much that I just use one function and tell the function which column I have to use it to create the one-hot encoding is the gender, and it will do for me. Here I'm just concatenating the newly created variable into the original data frame. And if you see here, I'm dropping out few columns. So dropping out is nothing but simply deleting few columns. So there are scenarios in in your modeling experience that that few of the columns will not make any sense for me if I include it in the analysis. And I'll give you an example. If you see surname, okay, now obviously surname will not make any sense for me if I include it into my analysis, because people leaving the bank and having particular one surname has absolutely no relationship between them. All right. Similarly, geography with with experimentation, I know that geography has no connection with the people who are going to leave my company. The last I'm removing gender is because I have already created here a dummy variable for it. So I'm removing the original gender, which has male and female as a character. and the resultant data that you see now is this, which is all numbers now. Because surname and geography I have completely got rid of, so I have deleted those columns. Gender I have converted male female into 0 1 here. So 0 means female, 1 means male. Okay. So this is how you do a data preparation. Now let me remind you that this is just tip of the iceberg. Okay, there are a lot of another methodologies are involved into this phase, and we will see each one of them when we deep dive into that particular module. With my experience, I can tell you that what are the processing step we do into production level projects, and that will help you in your longer run. Okay, so this is the typical small scenarios of a preparation. If you go down from from 20th, what you see now is your modeling. Okay, so we have reached this particular stage, modeling. What modeling particularly do is there is a principle that we follow is we always split our data set. Okay, so we don't use the same data set to train and test it. So we train on one set of data set and we test it on the another set of data set. So if you see here, there is again I'm using a pre-built function for that. There is no rocket science. I have just used a function and I'm dividing the same data set into two, train and test. Okay, so this is the X train, X test, this is the Y train, Y test. And don't get confused, I'll tell you each of them into detail and how to use them. And now this is the area where I think pretty much everyone is interested, how to apply a machine learning algorithm. And you will be very surprised to see that applying a machine learning algorithm is only 2 lines of code, the ones that I have highlighted. These are the only 2 lines of code that you write to apply any algorithm. However, to reach to this level, you have to spend a lot of time and create the data. And that you will not find in Google or any other website. That will always come with the practice and instructions or sharing and experiences with someone who have that earlier. It will not come, or it is not a Bible that it come from somewhere. So again, I have just used a simple logistic regression to demonstrate that how do we do it. It's just 2 lines of code. I have called it and I have applied a methodology called fit. So fit is nothing but it starts the training. Once the training is done, I apply a predict method on the test data set. So if you see here, the training is done on train, the prediction is done on test. Okay, so this is what the predictions I will get it on my one of the variable. And then now is the time that I evaluate the model. So this is this phase evaluation. And here you see, so this is a classification report. I mean, it will be too much if I download that information to you right now. But what it tells me that is how is the performance of my model that I have created here. Okay, so the major part that we see is accuracy, and it is around 78%. So it's pretty good, I would say, not very bad considering the base version of the logistic regression. I can fine tune it more, but as a base version, 79 is not bad. Okay, so that is how you check, that is how you evaluate it. And as I said again, applying an ML algorithm is just 2 lines of code. That's it, nothing fancy stuff. And yeah, this is another confusion matrix, is one of the terminology which tells you how good and bad is your model. And again, this is the average accuracy score that I showed you. So this is a fundamental action that we can create to solve any business problem. And this is what we do in, day out. Okay, and you can make relationship that what you will be doing once you jump into this kind of a area. If you like this kind of a stuff, if you like finding out the patterns, if your mind is so curious that you create stories around it, then you will do wonders in this kind of field. And course that we have created, the experience that I can share, we can make you so ready that you can jump on any project very soon. So I think I have covered pretty much what I have to cover, and I think I will open up now for questions if anyone have.
Can you give us a little idea about what kind of project we're going to cover over here, Puneet?
Okay, so my particular idea is so let me show you. So my fundamental idea is once we start the course, the projects, the use cases that we will take will be pertaining to every different sectors or every different domain. Okay, so why I will be doing that is because we never know that which resource or which student of ours will be placed into which kind of company, right? So with my 7-8 years of experience, I have created so much of use cases that we can share. So one of the use case that we just saw is bank churning. So we can see that in more detail with more realistic data, and this is one just logistic regression that we have applied, but we can do more complex algorithm there. Second use case that I would like to take is from this social media particularly. So how a student can connect to Twitter or to Facebook, get the data, apply NLP, which is like a natural language processing techniques, to convert that data into the analyst form. That is one of the use cases we'll be deep diving into. Okay. Third, the sales field that you see is another area which I'm pretty much interested is, I will be creating or I will be showing how do you create a recommendation engine. Okay. So I'm sure every one of us uses Amazon, and when you see any product, if you scroll a little down, you will see that there is a section which calls people who have bought this also bought this. It is nothing but a recommendation engine, and I created that for Asian Paints in one of my last experience, where we created a recommendation engine for a dealer. So I can share that experience. We can create a recommendation engine together to see how a recommendation engine real works, right? And in the last example that I would take in the BFSI domain is fraud identification. Okay, so let's say you have a transaction data set. How do you apply methodologies to find out if a particular transaction is fraudulent or it is a genuine transaction? So we will deep dive into this wide spread of applications and wide spread of use cases, which will be helpful to every student.